All right, so I'm Dave. Welcome to Thursday morning. A lot of you apparently did not drink as heavily as I did. So one thing, before I start, one thing that I really like about S4 is this is actually a really good community. And I think that everyone's kind of working together in a way that you do not see at other security conferences, including the vendors, which is kind of surprising. So I'm here to give them all a little bit of a little roughing up today. Yeah, that's clapping for you, which is good. It's a good way to start. So this talk is here to do a hacker's analysis of CISA's secure by design / default. Probably the first thing I would say is that is a very awkward name. But you've heard about it probably about 100 times in this conference. And you're going to be hearing about it 100 times more in the next conferences that you go to, and probably as you build your products and live your life. And I'm going to press play, and it's going to work. Or not. It's failing. Oh, there we go. All right. The little beeps mean it worked. OK, so I think probably like the question I think everyone has going into looking at a government program like this is, how much of it is pretty please, and how much of it is or else, which is very different for all of you in this room, including the ones building products, but ideally the ones buying products as well. And we're going to go over sort of the who, what, why, and how of the program as viewed by an outsider. And then we're going to talk about the what's right, what's wrong. So the who, pretty simple. I think you can talk about the progenitors of sort of the motto in terms of like, I think this podcast is very good to listen to. So if you have a spare hour and a half and you feel like you want to listen to Paul Rosenzweig, who does a great job moderating it, and then Jack Cable, Bob Lord, and Lauren, I'm going to mess these names up, so I won't even try. Lauren and Jen. That is sort of like, I would say, the best 101 introduction to the themes of secure by design. And I think Paul starts up the presentation, or the podcast, with a really good question. He's like, what in this is beyond, please change default passwords on your devices, right? So that is a great question, and hopefully we'll be getting into some of that as well. But I think the key feature of that podcast and all of the other things you're going to see about it is that there's a lot of technical people involved. There's a lot of people with industry experience involved. There's a lot of people who are reachable. There's like having a government program where there's a face and a name and an email and a phone number where you can call up and ask questions is a new feature. That's a new way of doing government, and it's good to acknowledge that's what you have. And you also have clear executive support. So when you see the executives, not just of CISA, but of ONCD and all the other pieces of the puzzle talking about secure by design, they're clearly on board, which is important. And so when you do policy analysis, there's a sort of concept called whole of government approach, right? So when you look at sort of Defend Forward, for example, if any of you have heard of Defend Forward, you will also hear them talk about a whole of government approach to Defend Forward. But what you're really seeing with secure by design is a whole of alliance approach. This is a fairly new development in how this is being done publicly. Obviously, there's always been an alliance behind a lot of government efforts. But publicly, this is pretty new. I don't even recognize all of the different little icons here. Is that the Czech Republic? Maybe. I'm not sure. It would have been nice to have a little review of that. But it's a pretty broad sweep. It's not just Five Eyes. That's a really important thing. And neither is this conference, right? So the job of securing the infrastructure that we all rely on is not Five Eyes dependent. That's actually pretty difficult for the US government to deal with. So let's talk about the what. What is it, right? When they talk about it, what do they say? And I want to focus just on the very initial 3 bullets that they give you, right? So if someone went to marketing school and they're like, give your audience 3 bullets. Right, so they did. Take ownership of customer security outcomes is the one they're going to talk about every time. And it's the biggest one, and it in some ways means everything. Right, so that's essentially the core of secure by design. The other one is embracing radical transparency, which at first I was like, well, what does that even really mean? But then if you sat through a lot of the talks in the past 2 days, you heard people say, well, we have S-bombs, but they're only 15% accurate. And if you want to look at them, you're going to have to sign an NDA, right? I don't know how many of you heard that talk, but that's not radical transparency. That's temporary transparency. I don't know what the right word for that is. But anyway, we want to embrace radical transparency instead, and eventually we will, right? So stepping closer to radical transparency is the goal, and building organizational structure and leadership, that's what you all are doing right now, right? So figuring out how to all get on board on the same page, that is literally what you're sitting through as you sit. So the philosophical backing of Secure by Design is, I think, quite literally a book from Ralph Nader, where he said, did you know things can actually change and you can make the world better, and it used to be much worse driving on the roads because every car company made it every customer's problem that cars were not secure to do what they were supposed to do. And it's sort of like something it's somewhat been forgotten how bad things used to be in roads. And you'll see this come up over and over again as the government talks about Secure by Design, which is that things can change. So we've all in this room gotten accustomed over the last 10 years to a certain way of doing business, to a certain way of buying and selling software and equipment. And what the government is trying to say with one loud voice is that that's not the way it has to be. And if you listen to them if you dive deeper, this is a quote from one of their papers. They say, we want you to build your products based on reducing the burden of cybersecurity. And the key factor here is that the burden exists whether you get hacked or not. The fact that you have to buy all of those things in the vendor room at huge expense, hire consultants, come to this conference, all of that is a huge burden. That's not a burden that should exist on random customers. So that is literally, so it's not just, oh, you got hacked, that's like we're changing whose fault that is. That is not Secure by Design. Secure by Design is you should not need to update. And if you look at some of the other things that they talk about as they try to develop it, they're saying this is a process in progress, right? So it is not static. Many of you attended the CISA meeting, birds of a feather, that was here a couple days ago, and you talked about a lot of things, and maybe didn't feel like you were doing anything progressive. But nonetheless, the fact that government is literally just killing themselves to get in front of you and get sort of your feedback is a pretty new feature of how they build policy, where usually they just do it to you and then you get to complain later, which is, I think, it's worth pointing out that this is a positive development. That said, the downside, obviously, is a lot of times you get sort of policy by group committee, which is not as good. And if you look at sort of what comes out of this, you get like collections of artifacts of like, how can a company say that they're doing secure by default practices? And obviously the first one, Paul Rosenzweig would be very happy to see that it is eliminating default passwords. But then you start getting into things that are really hard to prove one way or the other, right? So how does a company say we conducted field tests versus we conducted good field tests, right? So the whole point of a peacock's tail is that it's real hard to fake. It either is huge and inconvenient, showing that the bird is very healthy and strong, or it's not. These don't really pass that test, right? So, document your conformance to a secure SDLC framework. In this room, I don't think there's anybody who's going to go check that there's a documented SDLC conformance framework thing from your vendors, right? Like, who's going to be able to read that and analyze it and say that that was worth doing? Nobody, right? So that's sort of, this is where it starts, you start seeing how difficult the problem really is. And then you start getting sort of the turtles all the way down problem. Responsibly use open source software. And in order to do that, you should go check out this paper that Japan's Ministry of the Economy has put together, right? So I'm not saying it's not a good paper, it's a very good paper, but it's sort of like these are layers of difficulty in understanding if a vendor is or is not secure by design that the customer, again, is under the burden of figuring out. So let's talk about why. Why is, I think, an interesting, it's like, what is motivating the government this much? right? So if we look at industry thought leader, Dino Daizovi, who also has the best name in the industry, it's very simple. Security is hard because the feedback loop on all the decisions y'all have to make is hugely long. In this room's case, it's like 15 to 30 years. And the signal is real low fidelity, although it's real high when you get ransomwared. But when you get ransomwared, you often don't know how that happened. So it's really hard to figure out where the next foot should go along the path. And I think that's the problem that a lot of people are looking at solving. And if you literally just call them up and ask them, what is it that Secure by Design is meant to do, they'll say things like, we understand there's no easy one-size-fits-all solution. That's why we're coming to all these conferences and getting all the feedback. And if we can reduce 90% of the initial entry points, that makes the problem at least manageable by a small team that can actually handle these things. And then we'd love it if people used memory-safe languages. And it's interesting because if you talk to security professionals who do not do OT, they don't talk about memory-safe languages that much anymore. It's almost a solved problem. They don't really need it. The point where you need it is all of this old, tiny router nonsense that everyone in this room has that no one else needs to install, except maybe on your home cable modem. And likewise, they're really not here to take other people's thunder, right? So I think the best kind of government is here to acknowledge that they're just there to amplify voices that already exist within the community. And when you literally get them sort of off the record, which of course is not what I did here, they'll say, look, we're frustrated and we're scared. And that's a common feeling, right? Everyone is literally frustrated and scared. So let's talk about just a few things. I had an initial presentation, I had a bunch of examples of terrible things that had happened to us recently, but we've all lived through those things. And I think part of the problem is that as a government customer or a utility, sometimes you see stuff like this and you're like, what on earth were you thinking? Right? Like this, putting a little slash at the end of the URL is what cost me millions of dollars. This is how I got lockbitted from some random Russian. And it feels, you can understand the emotions behind it. It feels unacceptable, right? The United States government has to pay all of these expenses to do pen tests for all these utilities so that these things can be found. All these people make terrible choices, and yes, the US government is fed up. That's the why. It's very simple. And the details and the how are the most difficult part of Secure by Design. And you see that with the agencies struggling with them themselves. And I'm going to sort of run down a few of the options here as presented in public information. The first one, constant outreach, constant alerts, constant discussions, constant videos, conferences, talks. Here's an example. Malicious cyber activity against vulnerable web management interfaces, right? So like, this is, honestly, if this had come out 20 years ago, it would have made a lot of sense, but it's good that it's coming out now. You can read the rest of it a little bit here. They're like, look, we're doing a whole new series of alerts for a different audience, because there's 1 million audiences that CISA has to talk to and that the US government has to talk to. And they're like, we would like it if you would knock it off when it comes to putting weirdly simple exploits into your web managed interfaces on your external router. And there's a few things that I noticed when reading this. First of all, they use the Microsoft name, which I think is odd. I think that realistically, the US government should probably have their own names for these things, or call out the group directly. Call them out in Chinese. I think that'd be more fun than, well, Typhoon, right? Like, they read these. If I read them, they read them. And then the other thing is redefining WMI as a new acronym, which makes no sense, because WMI is already an acronym for a very common security protocol that most system administrators are very familiar with. And that made me feel like maybe a marketing person got their little hands on it and wanted to tighten it up a little bit. So that was weird, right? So that's maybe a little issue with their audience. So when you read the papers, what are people suggesting? Outsiders who are not really outsiders, right? So what is Andrea Matwishin suggesting? And she's making the very reasonable suggestion that we invest in starting up an entirely new government agency that has the regulatory burden to take this all on. As you listened to Stuart Baker yesterday, you understand this is very unlikely to happen. Like, to the point of, I read the paper, but I felt like maybe I didn't need to read the paper, if that makes any sense. And I don't feel like you have to read the paper or even hear about it again, ever, because that's how rare that's going to be. The second thing is software liabilities. You're going to hear about this 1,000 times in the next year. And I like to call it moving the dial via endless legal fees. But it's not a new idea, right? So Aristotle Xaphalos, I kill every name in this talk, right? And I think that's his real name. He was nice enough to point out, he's like, look, here's a European one from 2016, here's another one from 2008, here's one from 2006. If you go read the 2006 paper, it's the exact same as all the modern papers, right? So that nothing has changed in the suggestions or the basis of the law. And Lawfare, which does a lot of this sort of thought piece work, has a whole section on security by design. And you can go read a lot of these legal papers. They're not hard to read. So I know Dale, when he talked to ONCD 2 days ago, up here in these nice chairs, he said, oh, we're worried that hackers might think they're lawyers, because they're not. And I'm like, these are super simple papers to read. The law is actually not that complex, and y'all should feel comfortable that I think if you can listen to this talk, you can definitely read these papers. And this one, for example, shields up for software. CISA's nothing if they're not full of good mottos. Derek and Melanie put together like we would have one safe harbor and one inverse safe harbor. And all we think that you could do is you just take the common weakness enumeration list, which CISA manages, which I don't think they manage, but in this paper they do. And those are so bad. Just like if you have those in you, then you should be liable. Very simple. Same thing from Jim Dempsey, who's apparently an extremely famous and well-known law professor. And he wrote, look, he had a lot more that he wrote this, but he's like, look, log4j was unacceptable. If you have a bug like log4j had, or a path traversal bug, the weakness known as path traversal, I love how he does that, that's terrible. You should be immediately liable, obviously. And he's like, this will minimize the cost of litigation while incentivizing improvements in software security. And if you've ever heard a lawyer say they're going to minimize the cost of litigation, then you've heard some things. So that's, in a nutshell, just an overview. Where do we sit right now with Secure by Design? Let's talk about the roadblocks. Software liability is impossible. So this is the first roadblock, is that the primary tool that is supposed to be done to make all of this happen is literally impossible. And let's go over it a little bit more. Because at first I was like, well, what if I made this softer? It's difficult. It's complicated to implement. It's prohibitively weird. No. It's literally impossible. If you walk away with anything out of this presentation, I want you to understand that we've built an entire government practice on something that won't happen because no one technical was in the room with the lawyers. Because the common weakness enumeration list is just that. It's enumeration. These are taxonomies. There's a bunch of taxonomies. Taxonomies are not legal standards, and they're not meant to be legal standards. To quote Veep, it's a little bit like using croissant as a hockey stick. It doesn't do the job, and it makes a really big mess. And that's literally what they're trying to do here. Obviously, MITRE, here's a big list of them, version 4. And Kurt, who I tweeted at, was like, yeah, that's an insane idea. Why would anyone do that? So no one reached out to the technical community to say, hey, is this an insane idea, or is this something that you could do? And the reason is very simple. Enumerations, taxonomies, all those things, even SDLCs are not they're not a black box that gives you an oracle, yes or no, something good or bad happened. Here's an example of one of the 400 things in the CWE list. improper validation of syntactic correctness of input. So if you had anything that could be described as improper validation of input, then you should be liable, is what that legal paper literally says. That is the plan they are going with. When you listened to ONCD a couple days ago, he's like, we're going to get all the lawyers in a room and we're going to solve this problem. That is insane. Someone has to actually read these things and understand that this is not a path forward. And you get, Ravi he's a nice graduate student. He's like, well, what about all NIST SSDF or any of these other amazing things? What about the OWASP top 10? They're top 10 for a reason. These are hard problems to solve, right? Like these are just not the kind of thing you can hang legal frameworks on. And no one was bold enough to tell them that, which I think is fascinating. It's a fascinating roadblock. So we're going to start with that is impossible. And the other one is hackers get a vote. All the Volt Typhoon people are not stupid, right? They're sitting over there, they're looking at this, and if you do this, here's what I think happened. I don't know how many of y'all play Dungeons and Dragons, but I'm going to bet a significant amount. A significant amount, all right? So lawyers tend to be lawful good. Even when they're not good, they think of themselves as good. And definitely they're lawful. That's the whole thing. They have to believe, right? They believe there's a law that, if everyone lived by it, right? They believe the Supreme Court is there to help, right? Hackers are chaotic evil. By default, we don't believe the best in people, and y'all are in the middle. Y'all are just getting crushed between these two things. This is a little alignment chart that Doug Song, who founded Duo Security, now Cisco, put together, which I thought was actually pretty cool. We are not the cavalry, would be another way to say it. But look, software liabilities create a huge business liability, right? So maybe I can't break into some random vendor because they're actually really strong, but I can create all of these issues for them by hitting all of their customers through their product and put them out of business. That's a pretty significant vulnerability, and don't think we won't use it. And that's the kind of weird second-party effect that is not carefully thought up when you look at some of these legal proposals for software liabilities. The other one is secure build is real hard. So this roadblock, look, there's a lot of unsolved problems. Just huge mega mountains that have yet to be carved down by the toothpicks of computer science. And literally, this was, for the last 6 months, I've been working on some systems that were, like yours, very difficult to secure. So the actual problems were the best of the Chinese were going to attack them. We have a realistic budget, and it has to sit around for 30 years. What's your plan? Right? What are you going to install? I don't know, is the answer. The difference between adhering to these principles and saying you adhere to them is really difficult. So it's really hard to figure out, this is what I want, but I don't know how to get there. And what I love is when CISA sort of calls, in this case, they were calling Microsoft out. They were saying, look, please stop charging extra for various security features. When you buy a laptop from Microsoft, if you want BitLocker so that you can leave your laptop in your hotel room without having to worry about it as much, that's extra money. You gotta get Pro. Why is that the case? There's no good reason for that. So yeah, people are getting called out. And it's, software's not a homogeneous market. Even this market in this room is not a homogeneous market. And I think one of the weird things about CISA's plans to do critical infrastructure is that, of course, K through 12 is a critical infrastructure in the plan. K through 12 and a water plant have very different requirements. So we talked about whole of government approach. You saw ONCD on stage a couple days ago. And I think it is actually very fun to have a release from the White House on the White House website with all the iconography talking about memory safety. I think that's great, right? Please, White House, recommend programming languages to us. That's awesome. You know what I'm saying? This is fun. And the difficulty about this is, as Soft Fox Lad would say, and of course the internet was built by furries for whatever reason, everyone says we should move on from C and C++, But what we're really going to do is some hardware shenanigans where we have memory tagging, some allocators, some shadow stacks, some other stuff. We're just going to say we have memory safety even though we really don't have memory safety built into the language. So they're not confused, right? The technical community is not confused, and I think it's nice that the White House is putting that out there. And you'll see, look, I can't produce these names, but part of the problems are very difficult, right? The ABI, the interfaces between programming languages that everyone has settled on is the C ABI. And so this makes things very difficult in the real world when you're building real software to move off some of these languages. And weirdly enough, the White House paper recognizes that. So a little further down, if you read it, they're like, okay, so we want you to use C and C++, but there's certain places in the space ecosystem where even though this is a really important issue, we understand you can't have memory-safe languages that we would prefer, the one we would prefer obviously being Ada, but realistically it's going to be Java, right? So, and what they call out specifically is like, well, you need determinism and timing, you need garbage collectors, all that stuff, like, or you can't have a garbage collector if you want determinism and timing. And so it's really difficult. So they're like, well, the languages that meet your requirements are C and C++, of course, and then Rust. And I was like, well, you know what? I've been looking at Rust for so long, and I'm like, you know what? Let's take a look. Are there any Rust OSs that are suitable for space? And the answer is no, right? There's not. So that obviously is a problem that, I mean, I think it'd be fun for the White House to write one. I think they should get a GitHub, and they should write us a little OS and show us they know how to do it so that we can copy their example. That would be really cool. So let's talk about some future problems. So hackers spend all their time, honestly, trying to look at the future a little bit. Projection and forecasting is a really important part of targeting. Most people don't understand how much effort goes into writing a new exploit on a product. And a lot of that is forecasting, because if it takes you a year or 6 months to write that, and then maybe another year to sell it or use it or operationalize it, you need to know ahead of time what is interesting in 2 years. And one thing Microsoft did was they were like, we are going to announce sudo. Sudo is obviously a Unix utility. One true operating system had something called, actually it's switch user do instead of super user do, which is what I thought it was. But they're like, we're going to announce sudo. Very cool. And then a Google researcher by the name of James Forsaw was like, that was cute. You wrote it in Rust, but it's still extremely ownable because you got all the logic wrong, right? Because you used RPC. RPC is more a font of evil than memory corruption ever was. And if any of you have used or tried to use Microsoft RPC, you understand it is from a world of pain. So I thought that was interesting. And then I was like, you know what? Microsoft used Rust. Let me take a look at Rust. Rust just looks like this. That's not scary. There's nothing scary about that. I'm like, let me write a little graph algorithm in Rust. Sorry, this is the most code that you guys have to look at, right? So I don't want to make this a super technical talk. So at a certain point, though, I was like, all right, so at what point did I have to understand what it means to have a weak edge that I borrow and upgrade from? Right? So these are things like my C brain, my tiny P brain was trying to figure things out. And so I asked GPT-4 to explain my code to me. And GPT-4, in its infinite wisdom, was like, of course, stupid. The edges field of node uses a weak vector node instead of a vector RC node to store edges to prevent reference cycles. And I'm like, oh, wow, I got to start using my computer science degree now. Right? So I don't know if you knew this, but most programmers don't use their computer science degree. And we don't want to. Right? So to use Rust, though, you do. You get to use all of it. You get to use all the edge cases of your computer science degree. All those classes you actually slept through and completely forgot existed, you're here now. Right? So why isn't Rust more popular? Well, I'm lazy. Right? So that's the answer. The other thing I noticed is we're really not good at seeing new bug classes when they begin. Right? So the theory behind secure by design is often that we can kill off whole bug classes. But do you know which ones you want to kill off that you would invest a whole of government effort in? Because the answer is realistically, it's not memory safety anymore. It's deserialization. It's a lot of other issues. How did everyone get owned last year? Well, they got owned through deserialization bugs in Java and C#. That's how people got owned. And we tried to warn people. I did a little experiment where I explained, like, hey, everybody, SharePoint is an absolute nightmare to secure, and you're never going to get it right, and it's going to let everyone in your systems. And I just said it for a bunch of months, and I just waited, and yeah, eventually, obviously, a SharePoint bug came out, and everyone got owned. That's what happens. But actually, no one kind of looked backward and was like, yes, you're right, we should not have SharePoint exposed to the internet or on all of our most trusted systems. The other thing that's big now is obviously CPU bugs, right? Like, it's no mistake that the Russians have sort of looked at all the microcode of the CPUs and are doing analysis at the CPU level. That's something that they're getting better and better at. You have to look at where your adversaries are going and go to where the ball's going to be. And that's sort of strategic weakness you look at in Secured by Design, is we are definitely looking at where the ball was 5 years ago. And if you want to look at where the bugs or where the ball's going to be, you have to look at orange size, algorithmic attacks, all sorts of CPU attacks, and then stuff that I don't really want to talk about on stage because a lot of people here in public, but I can guarantee you hackers are looking at the next big thing. They're not looking at the stuff that was here 5 years ago, except in this room. And the last question, and I think this was the biggest one, is what does CISA really want to be? Right? So CISA is not the NSA, and you don't want it to be the NSA. CISA is the front door, right? The NSA is the back room. When I worked at the NSA, yeah, we were pretty antisocial people because that is literally how the job got done. That's not true for CISA. And there's an element of that I think is really interesting. Like when you look at like the things on CISA's GitHub, yeah, there are a bunch of Zeek modules to help package it up to get it where people in this room would need it to be. That's very different from looking at the next bug class. It's a very different kind of problem set. And I want to just point out this, obviously, this is not a talk on, you know, what should we do, because I think everyone in this room has opinions on what should we do. But this is one thing that you can see we are obviously getting wrong in our strategy right now, which is when we give federal agencies 48 hours to disconnect Ivanti VPN tech. Ivanti has PHP on it. PHP is not okay. I'd much rather have you write your CGI scripts in C than PHP. There's literally no way to make PHP secure. And the minute, I mean, Ivanti's been getting owned left, right, and center, and PHP is not their only problem, but it's definitely one of their problems. So one thing that we're clearly screwing up here is that when we see people with continual problems, we patch them. Patching is not a solution. There's just no way to patch your way out of this problem. And you can see people realizing that. I don't know why they're realizing this the hard way when it's such an obvious feature of how we do business. Every hacker has said, oh, you're going to, I don't know, you're going to check to see if I'm here. I will make sure that the file system does not see me here when you check. It's not complicated. And they're like, oh, wow, factory reset can't be trusted? That's right, because you asked me to do the factory reset, right? Like, I own the router, therefore, when you say factory reset, I say, done. Good job. Security complete. And this is the only solution you have. And eventually, we all get to that. We find bad things, and we yeet them into the sun. And that is literally all that we can do that we know works. You've got to start somewhere with maybe an abacus, right? So I think this is, unfortunately, it's an obvious path where we all sort of go through the levels of pain until we do this every time. And I think it's fun to watch CISA and the US government in general update their sort of recommendations and analysis slowly into this sort of sphere. That's my metric. Everyone has to have a metric. My metric is days until you yeet Ivanti into the sun, or whatever the next Ivanti is. Okay, so in conclusion, what is the future of Secure by Design, said by somebody who has no control over it, but who can project into the future? And I would say, look, it provides a surprisingly strong base for being proactive. Having one voice and one message is amazing. And I think it's sort of weird when you look at government programs, because it's easy to critique them without realizing getting hundreds of people to work together in this space is really complicated. And these are people often who speak very different languages. I think it is really unlikely that legislation is applied that cements any of this into law. So the software liabilities thing, you know, if you've ever been a parent, you've threatened your kids with stuff that you're not going to do, right? You're like, you know, like, you're going to have to go to bed at 4. I'm going to come sit next to you, make sure that happens. You're not going to do it, right? So whatever it is, the same thing with software liabilities. No one's going to do that because these are terrible ideas that like 5 seconds worth of looking at can tell you are terrible ideas. But things are changing. So I think the idea that change is possible, that CISA is going to be pushing through change, that the OECD is going to be pushing through change, it's going to be a multi-administration effort. This is not something that is just going to stop at the end of one administration. Change is afoot, and I think it'll be really fascinating to find out what CISA decides to become in the future. So that's what I'm still looking for, and thank you so much for listening to this, and I wish you the best in your future Secure by Design moments. And that's the end.